How many three-digit positive integer multiples of 6 have the property that when the digits are rearranged, the new numbers are still divisible by 6? All right, well, okay, so we have three-digit positive integers, and they're multiples of 6. Okay, so what does that mean? If the number is divisible by 6, then it's also divisible by 2, and it's divisible by 3. And the divisibility rule for 2 just means that the units digit is even, okay? And then the divisibility rule for 3 is that if we sum the digits in the number, then that digit sum has to be divisible by 3 as well in order for the whole thing to be divisible by 3. All right, so those are so our numbers have to satisfy both of those things. So the digit sum has to be a multiple of 3, and the last digit has to be even. But we also want to be able to rearrange those digits and still get a multiple of 6, right? So if we rearrange the digits, it's still going to be still going to be a multiple of 3, because the digit sum isn't going to change if all we're doing is rearranging the digits. The only thing is that if we want it to also be divisible by 2, then essentially all the numbers have to be even, because if we have a number like 1, 2, let's say 1, 3, 1, 3, 2. Okay, that's divisible by 3, and it's divisible by 6. But if we rearrange those numbers, then if we put 1 in the units place or 3 in the units place, then it's no longer going to be divisible by 6, right? So, but if all of the digits are even, so if we had like let's say 2, 4, 0, okay, then the digit sum is 6, so it's divisible by 3. And no matter how we rearrange those digits, it's still going to be divisible by 6 because all the numbers are even. So it's going to satisfy both the digit sum has to be a multiple of 3 and that the units digit is even no matter how we rearrange it. All right. So, all right, let's look at some different cases. Let's see. So I'm going to look at case 1. And for case 1, I'm going to assume that all the digits are different. Okay, so all different digits. Okay. So let's list out the numbers that we could have to work with. We've got 2, 4, 6, and 8, and then we've also got 0. A 0 is kind of a little bit of a special case because 0 can't be the leading digit if it's a 3-digit number, okay? Because if you put a 0 in the first digit, that's not a 3-digit number anymore. It's now a 2-digit number. So we're limited when we're using 0. All right, so let's look at the case where well, let's just look at here 2, 4, and 6. Okay, so if we add that up, that gives us what, 12, which is divisible by 3. So 2, 4, and 6 give us one number that can be rearranged in any way and still give us a multiple of 6. Okay, so then we have to look at how many ways there are to arrange the digits within this, because all the arrangements of this number are also going to be divisible by 6, and will have the property that you can rearrange the digits and get a multiple of 6. Okay, so how many ways can we rearrange these digits? So well, we got 3 different numbers, and so we'll have 3 choices for the first digit, and 2 for the second, and 1 for the third. Okay, so essentially we can get 6 rearrangements of 2, 4, 6. Okay, or you could list them out: 2, 6, 4. You could have 4, 2, 6. You could have 4, 6, 2. You could have 6, 4, 2, and 6, 2, 4. All right, so those are all the arrangements of 2, 4, and 6. All right. So let's look at another set of three numbers that will give us a multiple of 6. So I'm seeing here 4, 6, 8, that's 18, so that's divisible by 6. So we can take the rearrangements of 4, 6, 8, okay, and we'll have the same number of rearrangements. There's 3 different digits. We have 3 choices for the first digit, 2 for the second, 1 for the third. So we're going to have, again, 6 arrangements of 8, 6, or 4, 6, and 8. Okay, so that's 12. So let's look at some more. Well, I see that 8 and 4 add to 12. So 4, 8, 0 is going to be another one. Now this one we're limited because we can't put 0 in the first in the hundreds place, okay? Because otherwise it won't be a 3-digit number anymore. So the number of ways we can arrange this is a little bit different. So you can think of it in terms of how many places do we have to put the 0. We've got 2 places to put the 0, okay? And then let's place the other 2. So let's say we place the 4 next. We get 2 places left, so 2 places to put the 4, and then finally if we place the 8, you're going to have only 1 slot left to put it in. So we're going to have 4 ways to arrange 480. Okay. And let's see if there's any more. How about 2, 4, and 0? So if we have 2, 4, and 0, it's really, as far as the number of arrangements goes, it's pretty much the same reasoning as for 480. You're going to have 4 ways to arrange the 2, 4, and 0. Okay, so I think that exhausts all the possibilities for the combinations of digits that give you all even digits, and the digit sum is going to be a multiple of 3. Okay, so what do we got here? We've got 12 plus 8, which is a total of 20. All right, so the total number is 20 for the case where we have all different digits. So let's look at another case. Let's say, well, another easy case would be the case where you have 3 repeated digits. Okay, 3 repeated. 3 repeated digits would be like 2, 2, 2, 4, 4, 4, 6, 6, 6, 8, 8, 8. And you know that if you add those digits, you're going to get a digit sum that's a multiple of 3 because you got 3 of those numbers. All right, and it doesn't matter how you rearrange these because they're going to be the same no matter what, the same number. So you have 4 cases there. So let's look at another case. Let's look at, I'm going to just write it here, case 3. And so this would be, I'm going to take the case where you have 2 repeated digits, and then the other one is different. Oops, let me erase that. Okay, so you have 2 repeated digits. All right, so that would be something like, well, let's look at, like, you could have 2, 2, 8. All right, so 2 and 2 and 8 is 12, so that's got to be divisible by 3, and it's even, so it's also divisible by 6. And how many ways do we have to rearrange that? Well, basically, you're going to have 3 places to put the 8, and then the other digits are going to be 2. So you're going to have 3 ways to rearrange that one. Let's see, you're also going to have, let's see, we'd have like 8, 8, 2 would be another one, because that would be 18. Okay, so we'd have 3 ways to arrange that. And, well, I know 600 would be one, but that one, we can't really rearrange the digits without getting a 0, so there's only one way to arrange the 600. And then let's look at, how about 660? All right, so there's 2 repeated digits, but again, the 0 can't go in the first spot, so we only have 2 places that we can put the 0, and then the rest will be 6s, so there's only going to be 2 ways to do that. So if we add all that up, 6, plus 3. Okay, so we have a total of 9 here. All right, so we have 9 ways where we can have 2 repeated digits. And I think that's it. We either have all different, we have 2 repeated or 3 repeated. So what's our total? We had 20 plus 4 plus 9. So 9 and 4 is 13 plus 20, that's 33. So the total is 33. So we can find 33 3-digit positive integer multiples of 6 that can be rearranged to form a new multiple of 6, or it's still divisible by 6. So there you go.